Good afternoon, class. This is the spring semester of 2020 at College of the Sequoias in Central Valley of California. We're in the COVID-19 lockdown still. It's going to be this way through the end of the semester. Last class we did 9.1, or last video was on systems of linear equations, where every equation made a line or plane, a flat or straight surface. 9.2, we begin to explore nonlinear systems, the systems of nonlinear equations. So the easiest way to just dive into this is give an example. There we go. Didn't have the right screen up. Okay, so our example. We're going to start off with x minus y equals -4 and x squared plus y equals 6. So you'll notice the first one is a line. So we've got one linear equation. The x squared makes it not linear though, so one nonlinear. When we have something like this, substitution works great. Or can. So the easiest way to maybe do this, solve for x. Add y to both sides here. We get x equals y minus 4. We'll plug that in. And we expand that, y minus 4 times y minus 4. Remember, that's what that's saying. We have y squared minus 8y plus 16. I've still got plus y equals 6. I'll subtract 6 from both sides and combine y's in the same step. Get y squared minus 7y plus 10. You'll see this factors just nicely into y minus 2 and y minus 5. And we solve. We get y equals 2 or y equals 5. Now, let's plug that into our first equation. Plug into A. So I got x equals y minus 4. X equals 2 minus 4 is -2. That was when y equals 2. I get the point -2, 2. And if I plug in 5, I get 1. I get the point 1, 5. Does that work? I have them set up in Desmos right here. Let's take a look. -2, 2 is where they intersect. And they also intersect at 1, 5. So that worked. So this came up with more than one solution, but not infinite. There was 2 points of intersection. What if I had plugged into B? And if we look at the graph, that is the only points they intersect, okay? That's the only points of intersection. Or only points they cross. If we plug into equation B, well, I plug in y equals 2. I get x squared plus 2 equals 6. X squared equals 4. And we take the square root of both sides, I get x equals plus or minus 2. This generates two answers, 2, 2, and negative 2, 2. If we plug in y equals 5, x squared equals 1. We take the square root, we get plus or minus 1. And we get 1, 5. We also get negative 1, 5. We just saw that one works, that one works, that one doesn't, that one doesn't. Where is 2, 2? 2, 2 is right there. It's only on one of the graphs. Negative 1, 5 is back here. It's only on one of the graphs. It didn't work. So, what does this tell us? What's it tell you? Hopefully, it tells you what it tells me. When solving nonlinear systems, you should check every solution. Because your approach may have yielded bad solutions. Bad juju answers. Okay. And notice if you had done this the other way, I'm just going to put it back up there for a second. We had x minus y equals negative 4 and x squared plus y equals 6. If I had solved for x, or solved for what did I get here? I solved for y. Y equals x plus 4. And I plug it in, I get x squared plus x plus 4 equals 6. X squared plus x. I'll subtract the 6 over, I get minus 2. And x plus 2, x minus 1 equals 0, which tells us x equals negative 2 or 1. And again, depending on which one you plug it in, things happen. You might be better off. Let's see what happens if we plug it in here. Negative 2 squared plus y equals 6. This is 4. And we just get one answer, right? If I plug in x equals 1, and again, we get one answer. And those were the correct answers. And we would have gotten the same thing plugging them in here. So it just depends on what approach you take. They all worked, but one approach generated answers that were not consistent with the overall solution. So we just got to be alert to that. Okay. Let's take a look at another one. The next two we're going to look at are on the screen in the Desmos section. X squared plus y squared equals 9. And we'll use 9x squared plus 4y squared equals 36. So that's A. That's B. A is the equation for a circle. B is the equation for an ellipse. We will explore those in chapter 10. Their graphs and things like that, how they graph. What can we do here? Well, we still want to combine to eliminate a variable. Here, we could try substitution. Does that work? I don't know. I haven't tried substitution on this one. Let's subtract x squared from both sides. And you get y squared equals 9 minus x squared. And I can plug that in. And I get 9x squared plus 4 times 9 minus x squared equals 36. Nine x squared plus 36 minus 4x squared equals 36. If I subtract 36 and combine like terms, I get 5x squared equals 0. X equals 0. You divide by 5, take the square root, you just get 0. Well, if we plug that back in, you get y squared equals 9, y equals plus or minus 3 when x equals 0. I get 2 points, 0, 3, and 0, negative 3. We should verify them. Always need to check your solutions on nonlinear systems. And you just check them into both. 0, 3. If I put that in A, I get 0 squared plus 3 squared. Does that equal 9? 9 equals 9, yes. And if I plug it into B, 9 times 0 squared plus 4 times 3 squared, does that equal 36? The 0 squared is 0, 9 times 0 is 0. 3 squared is 9, we have 4 times 9, does that equal 36? Yes, it does. We look at 0, negative 3, and you'll notice not a lot changes here. The act of squaring a negative number makes it positive. Does that equal 36? 9 times 0 squared is 0. We've got negative 3 squared is 9. 4 times 9 does equal 36. So both solutions work. Circles, perfectly round. Ellipses are not so perfectly round. They're ovalish. They're ovals. So that's the oval. And we can see they only cross. They touch there. That's on both equations, and that's on both equations. Okay. Ready for another one? Let's kick it up a notch. The next two you see, give it a try. We're using a lot of the same strategies we used in 9.1. So A is going to be x squared plus y squared equals 6. B will be 3x squared plus 2y squared equals 8. pause the video and work this out. Let's see what you get. All right, I'll assume you paused it. Let's see. I want to get rid of coefficients. I want to eliminate a variable. What I'm going to do is I'm going to take this, I'm going to multiply this by -2. So this is -2a right here. I get -2x squared minus 2y squared equals -12. I get x squared equals -4. And when I take the square root of both sides, I get x equals plus or minus 2i. Okay, plug it in. If I plug in x equals 2i, I have 2i squared plus y squared equals 6. So 2i squared, I squared is -1. 2 squared is 4. 4 times -1 is -4. Add 4 to both sides. Y squared equals 10. And we get y equals plus or minus the square root of 10. So two solutions are 2i square root of 10, 2i negative square root of 10. And if we plug in -2i, the -2 squared is still 4, I squared is still -1, and this does not change. We just did this. So y equals plus or minus the square root of 10, and we get two more solutions. -2i square root of 10, positive 2i square root of 10. I'm sorry, -2i negative square root of 10. There we go. 4 solutions. Let's check them. A little tedious now, huh? So 2i and square root of 10. So in A, we have 2i squared plus square root of 10 squared. Does that equal 6? 2i squared, we said, is -4. Check. That one worked. Oh, you gotta check B though. My bad. Got a little hasty there. So 2i squared is -4 times 3. This is -12. Maybe I can write in steps. And this is 2 times 10. Does that equal 6? -12 plus 20 does equal, or 8, not 6, 8. -12 plus 20 does equal 8. So that one worked. We'll do the 2i minus and square root of -10. Or square root of negative square root of 10. Got to check them both. And you'll notice, since these are both squared and in both equations, this gets us right back to where we were. Three times -4 plus 2 times 10, does that equal 8? Negative 12 plus 20 equals 8. That one works as well. You're going to see, doesn't matter which ones we plug in, plugging in the negative in both equations gets rid of it when we square it in either x or y. All 4 solutions work. But none of them are real. They all have complex components in it. What happens if we look at that over here? We can see the graphs never touch. Not in the real plane. When you start looking at complex number theory, though, there are complex solutions that solve both equations. And guess what this means? You won't find them by graphing. Which sucks, right? Let's do one last one. Let's take a look at it. Absolute value, throw something very different in there. That's also nonlinear. So we'll look at x squared plus y squared equals 4. And b will be the negative absolute value of x equals y. You take a moment, try to solve this, see what you remember about absolute value equations. If we, oops, that's what I wanted. That's what I got right here. So if I solve that, I add the absolute value over, I get y equals absolute value of x, which means when you take it absolutely out of the absolute values, it becomes plus or minus x. And to be honest, when we plug it in, it doesn't matter which one we plug in. The act of squaring it clears the negative sign, and it becomes x squared plus x squared equals 4. 2x squared equals 4. X squared equals 2. Or x equals plus or minus square root of 2. So I have 4 answers here. When y equals positive x, wait. So I got to plug that in. What do we have? So x comma y. Let me do this correctly. X comma y. I plug in square root of 2. Y is the absolute value of that. Use this one. It becomes the square root of 2. If you use that one, it causes problems. This is wrong. That's incorrect. Y is forced to be positive. So the only answer there is y equals x. Because y can't be negative in that circumstance. Well, when x is that's when x is positive. When x is negative, we got y is negative x. So yeah, y equals plus or minus x is the correct way to write it. But it's a split system. That's what that means. So when I plug in positive square root of 2, I get square root of 2, and the other option for x was negative square root of 2. Y equals, when x is less than 0, it's the opposite of that, negative square root of 2, because that's x. So this is negative x. And this gives us negative square root of 2 square root of 2. So we have two answers. Square root of 2, square root of 2, and negative square root of 2, negative square root of 2. Sorry, I kind of bumbled that. It's a split system like this. It's piecewise, as they like to say. You should check it algebraically. Let's just see what happens when we plug it in. And what is the square root of 2? 1.414, just like they have here. So this is the negative square root of 2, comma 2. And this is the positive square root of 2, comma 2. So both of them do work. If you plug it in, you'll see that it works. That kind of wraps up 9.5. That's the idea there. You need to check all your solutions. And I'll leave that as an exercise for you here. This is an exercise for you. We just showed it was true under Desmos. And believe it or not, that's going to wrap up 9.5. Not a lot going on here. Peace.